Hey guys, this is going to be a video covering the 3.1 homework. Okay, so let's jump into it. So 3.1, which function does not belong with the other three? And so the thing about these functions is really not how they look, but what type of function that they are. And we talked about in class that a polynomial function cannot have an expression where, well, let's just say this, that pretty much that in a polynomial expression, if there's an x and if that x has a power, then that power has to be 0, or it has to be 1, or it has to be 2, or 3, 4. It has to be something like that. It has to be positive, it has to be whole, so on and so forth. And if it doesn't, then it's not a polynomial. And so in A, here's this x right here. This x is to the first power, so we're good. We have x to the fourth. And this right here also would mean that x is to the first power. So we're good here. That's a polynomial. For B, x to the fifth, x squared, x to the first. We're good. X to the third, x to the eighth. We're good. And then we have x to the fourth. We have x to the negative 1. Now that is a problem right there. So this right here is not a polynomial. And so it doesn't belong with the other three. If I have 5x to the negative 1, that's the same thing as 5 divided by x. And we can't have x in the denominator, so and have it be a polynomial. So there you go. So for 2, decide whether the polynomial is a function. If so, write it in standard form and state its degree, type, and leading coefficient. So for 2, is this a polynomial? Yes, because if there is an x, it has a power, and that power is at least 0, and then, or it's whole and it's positive. So 2, yeah, that's a polynomial. Is it in standard form? No, it is not. To be written in standard form, we need to have the powers of each term written in descending order. So the first term in this one, if we're writing it in standard form, should be 5x to the power 3. And then it's going to be negative 6x squared, then minus 3x, and then plus 2. So you can see this is to the power 3, 2, 1, and this one doesn't have an x term. That just simply means that it's x to the 0 power, and x to the 0 power is equal to 1. But we don't write it because it's being multiplied by 2. Okay, so what is the degree of this polynomial? The degree of this polynomial is simply going to be the term with the term where x has the highest degree. So this is a degree 3. It is not degree 5. It is not degree 6. You don't add up all of them. It's just degree 3. And the degree will tell us the type of polynomial that it is, and it is a cubic. If you need to remember the types, if x is of degree 0, meaning you just have a constant. So let's just say, for example, y is equal to 5. This has no x term in it. That means x is to the 0 power. This is a constant polynomial function. And then if it's of degree 1, it's linear. If it's of degree 2, it's quadratic. If it's of degree 3, it's cubic. And hopefully you don't get anything more than that, but if it's of degree 4, it's quartic. Okay? Let's try 3. Is this a polynomial? So checking out x, it's to the fourth. That's okay. this x is to the power 3, this x is to the power negative 2. Not a polynomial. If it's not a polynomial, then then none of this information really applies to it. We like to have this information for polynomial functions. It tells us a lot about the polynomial. But if it's not a polynomial, then none of this information is relevant. We can't really apply. If it's not a polynomial, then it has no degree. If it's not a polynomial, then we can't specify the type of polynomial. If it is not a polynomial, then it doesn't really have a leading coefficient because, maybe it doesn't even have maybe it doesn't even have x with a degree to begin with necessarily. So okay, so let's go to 4. Is this a polynomial? So this x is to the power 2, that's okay. This x is to the power 4, okay. Power 3, power 1. This is a polynomial. And so the term with the highest degree is this term right here. So we'll say h of x is equal to negative root 7 x to the 4th. And then the next highest term is 8x to the 3rd. And then plus 5 over 3x squared minus 1/2 x. So there's the degree, or there's a polynomial written in standard form. It is of degree 4. You can see that that's the highest degree. The type then is quartic. The leading coefficient is negative root 7. Okay, moving on. We have evaluate the function for the given value of x. So we're going to take this function right here, and we're going to plug in negative 2 for that function. So h of negative 2 is equal to negative 3 times by negative 2 to the 4th plus 2 times by negative 2 cubed minus 12 times by negative 2 minus 6. If you have a calculator, you can punch it in. If you know any shortcuts, use the shortcuts in your calculator. Okay, and so I'm going to pull up my calculator, and that's what I'm going to do right here. Just plugging in negative 2 where it needs to be. So negative 2, okay, so negative 3 fourth plus 2 third minus 12x minus 6. And I have negative 46. So h of negative 2 is equal to negative 46. That's what I have anyways. Okay. Let's try 6. So we have the function g of x, and we want to evaluate it at x equals positive 8. Okay, so I'm going to plug in 8 into everywhere there's an x. We're calling it g of 8. That's going to be equal to 8 to the 6 minus 64 times by 8 to the 4th plus 8 squared minus 7 times 8 minus 51. Okay. Alright, and then I'm just going to use my calculator. So let's see, we're going to do 8. That's what we're plugging in. And we have 8 to the 6th power minus 64. And then we have 8 to the 4th. And then we have plus 8 squared minus 7 times by 8 minus 51. And I got negative 43. So g of 8 is equal to negative 43. For 7 and 8, describe the end behavior of the graph of the function. Okay, so we've learned in class that to figure out the end behavior relies really just upon the leading term. The leading term is going to overpower any other term here if x gets really, really large or if x gets really, really small. So if x is like positive 20, positive 30, doesn't really matter. But as x gets larger in that direction, or as x gets smaller, so in the direction of negative 20, negative 30, negative 1000, so on and so forth, this term right here will dictate how it's going to behend at the end, because of the degree of this term is larger than the rest, meaning that whatever you plug in for x, like what we just did right here, whatever you plug into x, eventually as x gets really, really large or really, really small, it all just depends on this term, if the y values are going to be very, very big or very, very small. So this is a negative leading coefficient and the degree is 4. Because the degree is even, either on the graph of your function, as x gets really, really large, either as x gets really, really large or really, really small, both ends are going to approach large values or small values on the left and on the right. If it's a negative leading coefficient, they're going to get really, really small. If it's a positive leading coefficient and even degree, both ends are going to get very, very large. So it really depends on just those two things. So we have a negative leading coefficient, an even degree, so as x gets really, really large, y will get really, really small. As x gets really, really small, y will get really, really small. Okay, so how do I write that? Using the correct notation. So we're going to use end behavior notation. So let's start with describing the left side. So on the left side, what we're going to say is f of x is going to approach negative infinity as x approaches negative infinity. And that's just what we're saying right here. F of x is going to get really, really small as x gets really, really small on the left side. On the right side, and if we're on the right side, if you look at that illustration we have on the right side, we're going to get really, really small. So to say that, I'm going to say x is going to approach negative infinity as x is approaching positive infinity. So what we're saying here is that the y values are getting really, really small as x is getting really, really large. Okay? And there you go. So we have a left and right side graphing the describing the end behavior. For 8, here the leading term has an odd degree and a positive leading coefficient. If you have an odd degree, that means that the ends are going to go in opposite directions in terms of going up and down. So it can, on the right side it's going to go up, and then on the left side it's going to go down. Or on the left side it's going to go up, and on the right side it's going to go down. And so it's one or the other when it's an odd degree, and if it's a positive leading coefficient, then it's going to go up on the right and down on the left. If it was a negative leading coefficient, it would do the opposite. So let's first describe the left side here. On the left side, f of x is going down, so I'm going to say that it's approaching negative infinity. And that means if we're on the left side, x is going to approach negative infinity. So f of x is approaching negative infinity, and y is approaching negative infinity, and x is approaching negative infinity. On the right side, f of x is approaching positive infinity, as x is, whoops, I forgot to put my x right there. As x is approaching positive infinity. So on the right side, positive infinity, y is approaching positive infinity. Okay, let's try 9 here. So we have here negative leading coefficient an even degree. This means both on the left and on the right, the y values are getting small. So on the left side, and also just for the sake of illustration, it doesn't really matter which of these you write first. So I could say as x is approaching negative infinity. By the way, if you're approaching the left side, x is always approaching negative infinity. Okay? If you're approaching the right side, x is always approaching positive infinity. Okay, so as x is approaching negative infinity, f of x is going to approach negative infinity as well. And on the right side, as x is approaching, since we're on the right, that's going to be positive infinity, and f of x is going to approach negative infinity. So negative leading coefficient, positive or an even degree, both ends are going to go down on the graph, on the left and on the right. And then, one second, I made a mistake. This right here is the leading term. That one was tricky. This is the leading term. And so this means that the leading coefficient is positive. So this means both ends are going to go up. So they did not write these ones down here. Let me make sure. Yeah, the other ones were written in standard form. These ones are not. So, sorry, we're just getting more practice, that's all. So on the left side, we'll say x is approaching negative infinity, and f of x is going to approach positive infinity. So now we're saying that both ends are going up because it's an even degree and positive leading coefficient. So on the right side, we're going to say x is approaching positive infinity, and f of x is going to approach positive infinity. For 10, looking at the this term right here, so negative 5x to the fifth. Okay, so on the left side, we're going to say as x is approaching negative infinity, f of x is going to approach, like I said earlier, if it's an odd degree, the ends are going to behave in different behavior. So one's going to go down, one's going to go up, one's going to go up and one's going to go down. So in the case that it's a negative leading coefficient on the left side, it's going to go up. So we're going to say to positive infinity, and on the right side, it's going to go down. And on the right side, that means x is going to approach positive infinity, and f of x is going to approach negative infinity. Okay. For 11, describe the degree and leading coefficient of the polynomial function using the graph. So you can see, so here's what we're going to do here. We're going to state the degree, not necessarily the numerical, like the number of the degree, but if it's odd or even. And then the leading coefficient we're going to state as positive or negative. Okay, so this degree has to be odd. I can see that it's going to be odd because I can see on the left side it's going up, but on the right side it's going down. They're behaving in opposite behavior, and so that's an odd degree polynomial. I don't know specifically if it's 3, 5, 7, but I do know that it's going to be odd, and I do know that the leading coefficient is going to have to be negative because on the left side it's going up and on the right side it's going down. If it were positive, it would be the reverse. Okay, for 12, the degree here is going to be even. And I know that it's going to be even because on the left it's going up, on the right it's going up. And also, that means that the leading coefficient has to be positive. Okay. Here we're going to graph the polynomial. So, okay, so graphing the polynomial, first of all, I'm going to note that it's a negative leading coefficient and an even degree, which means on the left side it's supposed to go down and on the right side it's supposed to go down. So I'm going to keep that in mind, and now I'm just going to plug in values into the middle part to see where it's going to be in the middle before it reaches its end. So let's plug in 0. So if I plug in 0 here, that's just going to be gone, and I'm going to be left with 3. So I'm going to put a point right here. And then let's say I plug in 1. So if I plug in 1, 1 to the 4th power is going to be 1. 3 minus 1 is going to be 2. So I'll be right there. And if I plug in -1, -1 to the 4th is still going to be equal to +1. So that's not going to change. It's still going to be at 2. If I plug in 2, that's going to be 3 minus 2. Now I could say plus or minus 2. It doesn't matter if I plug in -2. It doesn't matter if I plug in -2 or +2 right here. It's being raised to the 4th power, and the outcome's still going to be the same. So this is going to end up as being 3 minus 2 to the 4th power is 16. So that's going to be equal to -13. So that's going to be right here, and that's going to be right here. And there you go. That's what our graph is going to look like. And again, we know the end behavior. It's just going to keep getting more and more negative. Okay. This one right here, I'm going to start by looking at the leading term. So it's a negative leading coefficient in an odd degree, meaning my end behavior will act accordingly like that. And then I can start plugging in values. I like plugging in 0, because if I plug in 0, it should eliminate a lot of my terms. So if I plug in 0, those are gone, and I'm going to be left with -9. So I'll have a point right here. Let's say I plug in 1. That's going to be 4 minus 9 minus 1. So that's going to be 9 minus 5, right? No. It's going to be 5 minus 9, and that's going to be -4. So if I plug in 1, I'm going to get -4. Did I do that right? If I plug in 1, and I plug in 1, yeah, right? I'm going to use my calculator just to make sure. No, it's not right. What am I missing? So if I plug in 1 right here, that's 4 times by 1 minus 9 minus 1 to the 3rd. That's going to be 4 minus 9 minus 1. 4 minus 9. Yeah, of course. Yeah, that's minus 1. So it's going to be 9 minus 3, and that's going to be equal to -6. Okay, I knew something was off there. Okay, let's plug in 2. Oh my gosh, I have my something else was really wrong here. Sorry, I'm not thinking straight. It's negative leading coefficient. So that means on the end it has to go, on the right it has to go down, and on the left side it has to go up. Sorry about that. So here I knew that, that's why I noticed this here, but my arrow was going up, and that didn't make sense because I know that this is going up initially, but eventually it's going to have to go down. Okay, so let's see if I can get that behavior by plugging in 2. So if I plug in 2, that's going to become 8 minus 9 minus 4. So that's going to become 4 minus 9, right? Am I getting that right? 8 minus 9. 8 minus 9 is going to be -1 minus 4, and that's going to be equal to -5. Why does that still feel wrong right there? No, that's right. It's going to be equal to -5. So when x is 2, let's see. I'm actually going to use my shortcut, make sure I'm doing this right, because I feel like I'm doing this wrong. 4 times 2 minus 9 minus 8. 8 minus 9. That's it right there. My math is so bad right now. That's going to be 8. So 2 to the 3rd is 8. There we go. And if I plug in 2 here, that's going to be 8. That's going to be negative 9. If I plug in 2 here, still going to be 8. So this is going to come out to be negative 9. So at 2, it's going to be negative 9. And then if I plug in anything else, I think it's just going to keep getting more negative. And so I can see here that it starts off like that, and then it's going to go down. Okay? I'm just going to use my calculator from now on. Let's just plug in negative 1. So if I plug in negative 1, I get 4 times by negative 1 minus 9 minus negative 1 to the third. And I'm going to get negative 12. Okay, so that's going to be right there. And then I'm going to plug in negative 2 now. So if I plug in negative 2, I'm going to get 4 times my negative 2 minus 9 minus 2, negative 2 to the third, and I'm going to get negative 9. So that's going to be right here. So it looks like it's starting to go up. Okay, let's see if I can plug in negative 3, see if I can do one more value before it gets too large. So if I plug in negative 3, I'm going to get 6. Okay, so right here, perfect. Okay, so I know that's going to have to go down to reach this point, and now it's going to have to start going up, and there we go. All right, let's try 15. Okay, so I'm going to start by plugging in 0. Also, the leading term here, okay, it's even degree, positive leading coefficient, so that has to be the end behavior right there. Let's plug in 0. If I plug in 0, that's going to go, and that's going to go, and I'm going to be left with negative 9. If I plug in 1, I'm going to get 1 minus 9 minus 1. 1 minus 9 is negative 8, and then that's going to be negative 9. So it's going to be right here. Seems weird. Let me double check, but I think that I did my math right. I'm trying to do my math a little bit better right now. So we're using 1, right? Okay. So that's going to be 1 to the 4th minus 9 minus 1 to the 3rd. Still negative 9, right? And that's okay. Let's try plugging in 2. So if I plug in 2, I'm going to get negative 1. We could try plugging in 3, but it might be getting too large. Let's check it. Yeah, if I plug in 3, I get 45. So let's plug in negative 1. And if I plug in negative 1, I'm going to get negative 7. So that's going to be right here. Let's try negative 2 and see if I get something. I get 15, which is up there. So we'll just say this right here. It's going to go up. I know that it has to go up this way because the end behavior. And then I'm going to just connect the dots here. Something like this right here. And then it's going to have to go up like that. And there we go. Let's try 16. This is the leading term. Yep. And it's a positive leading coefficient, but odd degree, so that's what the end behavior is going to show. Let's plug in 0. That's going to go, and those are going to go, and I'm going to be left with negative 4. So there's my point right there. Let's plug in 1. So we're going to plug in 1. I'm going to put this into a calculator. We're going to have x to the 5th minus 3x to the 4th plus 2x minus 4. And we're going to get negative 4. Okay? For 2, so let's plug in 2. And we're going to get negative 16. Right? Yep, we're going to get negative 16. Now that is looking weird. I'm supposed to be going up as x is going this way. So let's see if I plug in 3 and see if that starts to match our pattern or what we expected to. Yes. So if I plug in 3, I'm going to get 2. Okay, let's try negative 1. I get negative 10. Let's plug in negative 2 and see if anything changes. And I got negative 88. So, yep, it's going down there just like we predicted. Okay, so this means it's going down this way, and it's going to come and get to that point right there. It's going to have to go to that point. It might go up, but it's going to have to come down, and then it's going to have to come down and get this point right here. It might go down further than that too, but I do know that it has to go back up because we have to get to that point and then keep going. So it might look something like that. Okay, so we're done with the graphing. Describe the x values for which f is increasing or decreasing, and b when f of x is greater than 0 or f of x is less than 0. So let's start with a. So where are we increasing? So we are increasing, let me highlight where we're increasing. We're increasing right here up until that point, and then we're increasing right here. So we are increasing when x is less than 0, and we're increasing when x is greater than 2. Now we're decreasing here. So that's going to be, so for decreasing, we're going to say when 0 is less than x, and that's going to be less than 2. So that's how we would say that, that's where it's decreasing. Okay, for b, we're checking to see when f of x is greater than 0. That just means when f of x is positive. So this just means positive. And this means right here, negative. And we're positive right here. So just this is the defining part. This is positive. This is when the y values are positive. This is when the x values are negative. So we're positive. We're positive here and here. Now technically at 2 we are 0, which is neither positive nor negative. And so whenever I describe positive values, I'm going to say, let's say negative 1 is less than x, and that's less than 2, and x is greater than 2. So we're going to be positive from here, from negative 1 to 2, right? So from negative 1 to 2, but not at 2. And then we're going to be positive again when we're greater than 2. And then we're going to be negative here. So for C, we're going to be negative when x is less than negative 1. Okay, for 18, so for A, we're talking about increasing and decreasing. So where is the function increasing? So that's going to be here and here. So that's where we're increasing. So that's going to be when x is less than 2, or sorry, less than negative 1, and when x is greater than 1. So when we're less than 1, and then when we're greater than 1, that's whenever we're increasing. So increasing and increasing. And increasing and decreasing is when you read the graph left to right, it's the y values are going up. It's going in upward motion. Okay, and then you can see that in the middle part right here, as we move left to right, we are going down. And so that's going to be between negative 1 and 1. Okay, for B. Now again for positive and negative, so let's do positive first. Where is this graph going to be positive? And that's just going to be right here, and that's when x is greater than 2. So x is greater than 2. And then for C, where is it negative? That's going to be here and here, but not at negative 1. So I'm going to say when x is less than negative 1, and then I'm going to say between negative 1 and 2. So between -1 and 2 right here, and when x is less than -1. And then for 19, sketch a graph of the polynomial function f having the given characteristics. So these characteristics stated here. Use the graph to describe the degree and leading coefficient of the function. So f is increasing when x is between -2 and 0. So I'm going to make some lines right here. So -2 and 0. And then x is greater than 2. So I'm going to put here where we're increasing. So f is increasing between -2 and 0. So we're increasing here. And then we're increasing when x is greater than 2. So we're also increasing here. And then we're decreasing when x is less than 2. So we're decreasing here. So this means that the graph, when I'm reading left to right, has to be going down like this right here. And then it has to be increasing, then decreasing, then increasing, like that. Okay, now before I write anything in, let's see where it's positive. So where it's positive, so a good thing to know is that whenever it's positive and negative, that has to deal with what's happening with it at the x-axis, pretty much when it crosses or when it touches the x-axis. So when f of x is positive, that's what that means right there, when x is less than -3. So I'm going to put a dot right here to tell me whenever it's going to change. And then it says from -1 to 1. So I'm going to put a dot right here and a dot right here. And then when x is greater than 3. So a dot right here. So basically we just found where it's going to touch or where it's going to cross the x-axis. Now let's go ahead and draw our graph. So we're decreasing here, so we have to be coming down. And I know that I have to be coming down, and I'm going to have to hit the x-axis right here. And then I have to keep coming down because I'm going to decrease up until this line right here, and now I have to turn because now we're increasing. And we have to start going up, and we also have to hit this axis right here to go positive again, and then up until this line, and then we have to turn around, and we have to decrease here, and we're going to decrease and cross the x-axis here, and then we have to turn around again right there and get the x-axis there and increase. So that's how I like to do those ones. So I like to use lines to separate intervals of increasing and decreasing, and then I like to put points on the x-axis to whenever it's positive or switching from positive to negative. Okay, and there you go, kind of a long assignment, but there's 3.1.